DeepState is a unit test framework that provides C and C++ developers with a common interface to several symbolic execution and fuzzing engines. We're going to show how DeepState can help developers significantly improve the testing of their software while remaining within the familiar unit testing paradigm developers already know well how to use. In this C++ code, we can see a function that squares a number. There are two unit tests to verify the function works: squaring of 0 and squaring 2. However, the code contains a subtle problem that can produce incorrect results. The type of the return value of the square function can't represent all possible results of squaring 16-bit numbers. Some results will be silently truncated to an incorrect value. As expected, the unit tests defined by the developer are not enough to detect this issue in the square function. DeepState allows us to define properties for our code where the input is symbolic, so it can take on any possible value. In this case, a 16-bit symbolic unsigned integer will be used. In the following line, we ask DeepState to assume that the value is positive. Finally, the last two lines contain the assertion with the mathematical property we want to verify for the square function. A developer should define such properties for their code, and DeepState will take care of how to verify the properties or show counterexamples demonstrating that the code has an issue. We use DeepState to check the property and find counterexamples. For this demonstration, we're using Manticore, our symbolic execution engine. DeepState can use other backends such as Anger, libfuzzer, or AFL. After a few minutes, DeepState identifies an input to show that the code has a problem. And we see that 258 squared is too large to fit in a 16-bit return type. DeepState saves the test case in a file so we can replay it later without rerunning the symbolic execution. If we want to use a fuzzer like libfuzzer, we don't really have to change anything in the code. We just compile slightly differently. DeepState can easily use fuzzing to generate a large number of inputs and try to find a counterexample for our square property. It's worth mentioning that it doesn't perform an exhaustive exploration, unlike symbolic execution. Symbolic execution is very thorough, but it often cannot scale to large programs. Fuzzing scales, but is less complete. DeepState gives you both without needing to rewrite your test. Here we see that the square of 51657 is also too large to fit in a 16-bit return type. libfuzzer finds the problem almost instantly, unlike Manticore, which takes a few minutes to produce the result we need. After we fix the issue in the square function, we can use DeepState to verify that the code now works. Our return type is large enough to contain all possible 16-bit squares now. If we run Manticore, it will tell us that there is no counterexample. The property holds and our code is correct.